Hello science fans, welcome back to Science Fun with Austin. Today we're going with a viewer suggestion from Brian in Minnesota, who suggested a way to map the wave pattern in your microwave. So we're going to give it a try here. We have some thermal paper, kind of like you'd find for a fax. It can actually be a little hard to track down, but like an Office Depot or someplace might be somewhere you can go. We've actually soaked it in water, and I've added about a tablespoon of sugar to kind of try and improve the imaging. And we're going to take the paper, shiny side up, and place it in the bottom of the Science Fun microwave to try to get a map of what the wave pattern inside the microwave looks like. Let's see if it works. Get the inside covered there. We have to soak the paper in water because although the thermal paper will give an image, without water or something on it, there's nothing to cause the paper to heat up and form the map. Alright, just to give you an idea of how warm the paper actually has to be to change color, we will very carefully heat it up here. So you can see you can definitely get a change effect, but you have to be well over 100 degrees to get that to happen. Well, we found out that getting the paper wet renders it ineffective. So I tried using a couple of plates to keep the paper contained and heated, but I think instead of mapping the microwave, I may have just mapped the contact pattern of the plates on the paper. So I'll have to try a couple more trials. Alright, well it's taken a little experimentation to come up with a method that seems to work. But first off, on the back side of the paper, the non-shiny side, if you want a reference guide, it's helpful to put axes labeling how the paper was in the microwave so you can interpret the map. Then, the issue we have is we need a way to heat the paper up without soaking it enough to smear all the coloring. So what seems to work fairly well is placing the paper on top of damp paper towels, shiny side up. You want to make sure that to smooth your paper on top of the paper towels here. Otherwise you'll end up measuring how well the thermal paper stuck to the paper towels and not what your wave pattern in the microwave is. Slide that in there. This is a 600 watt microwave, so we'll let her cook for about 2.5 minutes. You'll probably have to play with yours a little bit to find a power level that works. And then as soon as we're done, we'll take it out to avoid having water from the paper towels soak in and smear the map, and to improve the curing. So let's see what we get. So another way you can try to map the wave pattern in your microwave is to use a delicious food item like these brookies. We'll let these warm up for a little while. And you can definitely see a pattern of hot and cold spots in the delicious brookies. Right here you can see the middle of the Science Fun microwave actually isn't getting heated all that well, but if you go off to the edge a little bit, we're definitely warm. You can range from about 78 or so to well over 100 degrees. Well, I ended up bumping up the cook time on the paper to about 4 minutes to try and get a little bit better image, and it seems to have worked. But it took a lot of trial and error to get the paper to work, and I've heard a few people out there don't go out and buy infrared cameras for their iPhones. Fortunately, there's a quicker and tastier way to map your microwave. You can simply make yourself a lovely quesadilla. Remember that finely shredded cheese yields higher resolution. And watch the melt pattern. And if you look, it seems like the cheese and the fax paper agree pretty well. There's a little bit of a melted spot on the left side of the cheese that we also saw in the infrared that we don't see on the paper. I think the base might have peeled up a little bit. But this way is much tastier to clean up. So until next time, have fun, science fans!